Welcome you all. So this is our 3D printing machine we have here. So this is the machine, you can see the entire model we have here. Similarly we have this machine, and then that machine we have, and even this is one more machine we have. So these are of different specification, and the operation is different here. The technology used in these machines are different. So talking about this machine particularly, so we have this is a FDM based machines. This one, even this machine and this machines, these three machines are FDM based, that is fused deposition modeling. In fused deposition modeling, what is happening is that we are fusing something and we are depositing it. Simply, this is the meaning. So we are using a filament based material we have here. So I can show you some of the filament based material. Fine. So this is the material we have here. This is called the spool. The entire section is called spool, and we have, this is the filament we have here. So all these three machines, this one and that one, in these three machines we are using this kind of filament. This is a PLA material we have here. So this is a PLA filament we have, and this is the size of the filament, you can see. Fine. So we have this one, and the diameter is 1.75 diameter. The diameter of this one is 1.75 mm. This is the diameter of the filament. Fine. So talking about this machine particularly, we have this section. This is the section. This is called internal bay. A internal bay is a section where we can keep something or hide something. Fine. So this is the bay we have here, internal bay. This is bay 1 and bay 2. In the bay 1 we keep the printing part. We have basically two different types of material we can insert here. In the screen you can see this is the material section we have here, and we have two different types of material we are using. This is model material. So for a particular model this material is used, and simultaneously we will be needing one more material that is for giving the support. So this is the support material, and this is the model material. So this is the thing we have here, and these are the blue lines you can see. So this blue line indicates that the materials are already inserted into the heater and the nozzle. So this is the blue line. If suppose I take it out, so it will be orange in color or maybe gray in color. The orange is the warning sign, and gray is the material is not properly inserted here. Here we can see 69% of ASA. ASA is the model material we have here. Similarly we have ABS material, ASA material, PLA material, and TPU material. So in this machine, a single machine, we are using 4 different types of material. That is only for this machine. Rest of the machines we have different, the orientation, the configuration is different there. So in this machine we are using 4 different types of material, that is ABS, ASA, PLA, and TPU. All these materials are thermoplastic material. Thermoplastic material is in the sense is that when we heat the material, we can fuse it and we can deposit the machine. So these are all thermoplastic thing we have here, basically a plastic material. Fine. So even we have here support material. Talking about the support material, we have the name here, you can see in the screen. So similarly here in the model material we have ASA. In the support material we have QRS. QRS is also a thermoplastic material. Fine. So here we are having 69% remaining of material. The amount of material remaining is 69%, and here we have 25%. Fine. So this is the material we can see here. We can view here the condition of the material. We can see the temperature of the material we have. This is the temperature. Now the present temperature is 88 degrees Celsius, and here we have 89 degrees centigrade we have here. So almost same. So this is the current temperature of the filament that is inserted into the head. We have head here. Fine. Talking about this section, so we can open it. Fine. So you can see this is a ASA material, that is the model material. This is used for building the geometry. Fine. This is the only thing used for building the material. Similarly we can put here, currently we have ASA material here. We can put here ABS, TPU, and PLA in this section. So that is only used for building the material, the geometry, the part, the 3D part. Fine. This is the section where we keep the support. This is only for used only for giving the support to the printing part. Fine. So we can see this filament are going inside. These are the filament tubes. So it is going inside, and we have some motor here and some rollers here. So it gradually drags the thing and takes the thing inside automatically. We just had to we just have to put it inside this tube, and automatically it will drag that thing and take the filament inside the tubes, right? So we'll close it. Fine, we have here some storage section, so we can keep here some of the things. Fine, and we have this kind of plastic, that is most important thing I think. We are using this kind of plastic to store the thing, like suppose now I'm taking this ASA material and I want to put here ABS. So taking this out and putting it in some other place won't work, because it will catch some moisture. So to avoid the moisture content in the filament, we are using this type of plastic bags here. So we can note it down like QRS material. I've changed it on 24/12/2020, and the percentage was 60% remaining. So we can use this type of bag so that we can isolate the thing and we can keep it in a proper condition. Fine. So these are used for only for storing the filaments. Fine. We have some other place so we can put all the things. Fine. Talking about PLM, okay, first of all we'll open this. So this is the oven section here. This is the part where the printing happens. This is a plate we have here. This plate we can take it out. This is the plate over which the printing happens, and you can see we have printed something. So just to show you people, so this is the printed part we have here. Fine. So you can see this one. This is the part you can see. So we have some kind of lines here. So this is basically the support part. So first of all it will make a support over the base, and then it will start building. So similarly we have this support here, you can see. So these are the support material, and this is the actual printing part. Fine. And also inside you can see this is the hollow portion, and inside the hollow portion we have support material. Similarly we don't have here, we have one more here, support material here. Fine. So it orients in such a way that it automatically generates the support. Like we don't have the controlling power that we want to remove support material from this section and add it to some other section. Like suppose in this central section we don't have any support. So these are all the things are controlled by the machines. We don't have the capacity to add the support material in some other location where we need as per our necessity. So we have here, but we don't have here any kind of support material. So it is automatically given by the machine. Fine. So this is the part we have here. This is the ASA part, that is the main 3D printed part we have here, and these are the supports we have. Similarly in this section also you can see this is the support part. This part is the irregular parts of the supports part. This is the irregular part, and this is the support part, and this is the regular part. This is the fine tuned regular part. This is our 3D printed part we have here. Talking about this one, so in the demo class I told you about perch tower. Fine. So we have some kind of perch tower, and you can see the condition of this perch towers. You can see there are many dotted lines on here. These are the spools we have here, the irregular printing parts. So basically when the print head is traveling, when the nozzle is traveling, so suppose it is printing here something. After printing a single layer, it will move to this part. I'll show you. This is called flip. This is a rubber material. This is flip, and we have some brush here. So it moves to this part each and every time. After completion of one layer, it will move to this part, and it will try to clean the nozzle head. We have a nozzle there, and in the nozzle we have filament. Fine. So the nozzle is delivering the material, and it is printing a single layer. After printing a single part, each and every time it will move to this portion, that is the backside portion. In the flip and the brush, it will try to clean the nozzle head. After cleaning the nozzle head, it will come to this section where the perch tower is kept, and here it will try to print one more layer, same layer, the layer of this geometry. Suppose we are printing something here, and we have a circular disc here, and we are printing something of the first layer. After the completion of first layer, it will go somewhere in this section, and it will try to build the perch tower. The height of this one and that one will be same for the first cycle. Gradually when we are moving and building the thing, the perch tower will also come up, and it will maintain the same height. So what is the reason of giving the purge tower? The purge tower is basically given to check the height. It is continuously correcting the height of the 3D printed part. Like suppose we have this one around 65 mm or 55 to 65 mm height we have here. So the purge tower, what it will do, it will continuously check the height, whether the when the nozzle is printing the thing, the height is kept constant or not, or it is changing the height, some kind of problem we are facing. Basically one reason. Second reason is that it is the purge tower is continuously checking the flow rate of the filament when the filament is passing through the nozzle. So we may have some condition that the nozzle is not delivering up to its 100% capacity. Suppose it is delivering at a first layer, it is printed, it has given a constant flow rate, the flow rate of the filament. After the completion of first cycle, in this, when it is printing for the second cycle, the flow rate may not be 100%, it may be 20%, 30%. The amount of material flowing may not be proper. So to check this thing, we have this kind of thing, that is purge tower. So the purge tower is also taking care of this thing, that the flow rate is maintained constant or not, so that the amount of material we are receiving, that is correct or not. Second thing, if suppose the temperature goes down, like in Shillong we have, in winter time we have 5 degree 4 degree temperature we have here. So because of temperature drop, it is printing one layer, second layer, fourth layer. After the completion of fourth layer, in the fifth layer the temperature may go down, maybe by 5 degree 6 degree it may go down, the temperature of the nozzle head, the heater in the nozzle. So there, when the temperature goes down, we will have, obviously the thermoplastic won't be melted properly, and we will have some effect on the printing part. So also it is taking care of that thing. Secondly, if suppose the printing is overheating the nozzle, then what will happen? We will have excess amount of flow rate, and the diameter of the filament will be very less. It will be more like liquid. It will not be viscous. It will be more be like a non-viscous fluid. So to check all these things, a purge tower is built. Fine. So this is the use of purge tower. So similarly we have, you can see here. So in the purge tower also we have two different layers we have. Fine. This is the internal layer we have. One internal layer, one external layer. So these two layers are given, one for ASA material and one for support material. So it is continuously checking for support as well as for printing part, the main material, the model material. Fine. So we generally throw it out. So this is the part we have here. So we take it out, all this thing, suppose, and taking this out, just press it down, it will come out. Fine. Like suppose now this part is sticking to the bed. This is the bed we have here. This is the platform or build plate or bed we call. So just you bend this plate, just move it and it will come out. So you can see these are the support materials. In the base section we have support material, in the back side we have support material, as well in the front side we have support material. But if you look at this portion, these are very fine-tuned regular part, this part, this part. So this is our model, the actual model. Fine. So this is ASM material we have here. Talking about this portion, we have this head here. So in the head section you can see we have two different types of thing. So we can move it. Okay, fine, I'll show you. We can see here we have M and S. This M means model material and it is marked here. That is this head is used for only for model. Similarly we have here M and S and it is marked here S, that is support material. So this head is used for support material and this head is used for model material. These are the pipes coming and these are carrying the filament. You can see here inside, this is the filament material going inside. So we are inserting the filament inside this head. This is basically a heater and nothing else. This is a heater. The heater is connected to the nozzle. So first of all the filament is going inside, it is heating it up, and then it is delivering the heated part to the nozzle, where the nozzle is injecting the part in the build plate. Fine. Similarly for this one and this one, the working is same. We have a heater and then after the heater we have the nozzle. We have some chips here connected. These are the wires we have connected so as to give the movement here. So this section is called gantry. This portion is called gantry, where we have some rollers. You can see this is the tube, this is the roller we have here, and the belt drive we have here. We have some motor over here, and this is the whole setup where the main frame where it is carrying the two heads we have here. These are the two heads, and the entire section is carrying all these things, the motors, the heads and everything. So this is the section we have here. Fine. This is the oven section where the printing is taking place. This is the internal bay we have. This is the digital screen we have here. Fine. So talking about this one, like suppose these are the two slots given here. If suppose we are having some model in our pen drive, so we can use the pen drive, we can go in the plus symbol, and we have USB and internal storage. So the internal storage is, this machine is already having some memory, and in the memory it is storing something that is inbuilt. These are the models. You can see these are the model. The extension is CMB. So in this machine, particularly in this machine, when we are building something, the extension used by this machine is .cmb. Fine. This is the extension the machine is taking. Fine. And these are some inbuilt models we have here. It is given by the company. We don't have any pen drive connected, so it is empty. So we have USB here. So once we connect the pen drive, it will show here the thing. Fine. After this we can print it out. I will show you later. Fine. This is the material section where we can view the status of the material. What is the current status? Now I have opened the oven door, so it is showing 0 degree. Fine. Once I close it, it will gradually the 0 degree is not exactly like it is showing the present condition. It is just showing that to close the door. Once I close the door, it will again show the current temperature, maybe room temperature or more than room temperature. We have setting options, so we have something. This one is used for light on and off. This one is used for Wi-Fi. If we want to connect the LAN or Wi-Fi, so we have this option. We have this option where we can calibrate the tip. So tip here means the nozzle head. So we can go this and start doing. So you can see the image here. This is this part. This is the head part over here. So this is the two heads we have, one for model and one for support. So this is the tip we have. So we can go for automatic calibration, and then we can go for manual calibration. These are the calibration we do. We have similarly this thing. So this is the gantry section, as I showed you. So it will continuously show you the X direction movement, the Y direction movement, the Z direction movement. It will show you the chamber. This is the chamber. It will show the temperature of the chamber. Now previously we were having around 88 temperature. Oh sorry, that was for filament. Something else we had here. So you can see the chamber temperature. That is the chamber here. So currently the chamber temperature is 73. We have the software update and all. These are the this is the thing where it is showing that how many hours we have printed. So we have already 168 hours of printing already done. This is the home portion where we can see the which operation is taking place. Now suppose I was printing something that so the image is here. This is the file name. The FF is the file name. We have the amount, the time required for this operation. So it was 51.23. So it is showing these are the thing, and this is the what kind of material the machine is having currently. The machine is having ASA and QRS material, and it is showing the current status, like suppose 20%, 30%, 50%. So it will show here after the completion of all 100%. It will show you're done and the print is successful. So this is the basic function of the screen. This is the printing part we have. Talking about the software, so we'll just see now the software part, and before that I am going to show you one more thing. So this is the printing head we have here. This printing head is only used for ASA, ABS and TPU. Remember this thing. This one is only used for ASA, ABS and TPU. For PLA material we have different heads. Fine. This head. So this is the head you can see here. Fine. This head is similar to this head installed here. I am showing this one only, but these things are standard head. This standard head can't be used for PLA. This is standard because we are using for 3 different materials, that is ABS, ASA and TPU. So that is the reason that is standard. For PLA we have this type of head. So these are the specification and everything are same, but the heater the heater which is used here is different, so that is the reason we are using different head. So you can see here we have installed this one here in this way, in this direction. So this is the head we have here, this is the tip, and this is basically a nozzle. So you can see this is a nozzle, very small part. This is the rubber portion, this is called the shielding. Fine. When it travels and moves in this part, the brush we have here, this one is the brush. So as to prevent the metallic surface, we have one shielding here, and it will just wipe it. Fine. This brush is used only for wiping and cleaning the tip. Fine. So basically this is a PLA head we have here. We have heater over, this is the heater section. You can see we have some lining here we have. So this is given to reject some of the excess amount of heat. If suppose the heater is heating above the desired condition, so it will try to send this out to the atmosphere. This is the heater section, and this is the, we have some rollers here, and this is the nozzle here we have, and this is the part where the material flows inside, and this is the nozzle tip, the nozzle head. Fine. So this is the, this is basically used only for PLA material, and rest we are using for rest of the material, the standard one. Fine. So this is the basic part we have given you. The company is Stratasys, the model number is F170. Fine. So this is the basic function of all the things we have here. So talking about this, how does it work? So you might have learned about or studied about CNC machine. In CNC machine, what do we do is that we create a model, we create in a computer, we create a model, and then we send the model to the machine. In CNC milling machine or maybe lathe machine, so we are building a model and we are sending it to the computer, and we are just placing the material there. So suppose we have a mild steel block or maybe copper block or any other block. What we are doing is that we are fixing the block in the vise of the CNC machine. We are making a model and we are giving it to the machine. The machine knows that what the task is given. So as per the necessity, as per the desired model, the machine will do the machining operation there. So that is very simple thing. So how does it work? We have, when we create the model there in the computer and send it to the machine will extract the geometric codes and the machining codes. So it is as we all know that while operation, when we operate a CNC machine, we need to know the M codes and G codes. Fine. M codes is used for machine codes, that is machining codes. See, so once we know all this thing, the codes, we can run the motor, run the spindle, the coolant, all this thing, we have the codes there. So what the machine does is that once we create the model, it will extract the geometric code, and as per the geometric code, the cutting tool will move and will cut the part from the metal, from the raw material. So those are very conventional way of doing machining. We are doing their machining and we are getting the thing. In this 3D printing machine, this is called additive manufacturing. In the additive manufacturing, what is happening is that a layer wise a product is formed. Layer by layer by layer by, the thermoplastic is fused, and then a model is prepared. So similar thing, once we create a model in the software, we are giving it to the machine. The machine is extracting the geometric codes. So at a particular time, what should be the X direction movement, Y direction movement, and Z direction movement, the machine knows. For the first layer or maybe the last layer or maybe the middle section, where should be the nozzle head, it already calculates the thing, because it is extracting the geometric codes from the CAD model we are giving to the machine. Right? After the extraction of the geometric codes, it knows what to do and what not. Right? So here the only difference is there, it is using additive manufacturing. In additive manufacturing, we are adding the thing. In lathe machine or any other machine, we are removing the thing, so that we are subtracting. So there are those machines are called subtracting type of machining process. Here this is called additive type of machining process, because we are using a nozzle head, a filament, and it is adding layer by layer, and it is forming the thing. And how it is forming? By taking the geometric codes from the model we are preparing. Fine. So this is the basic part we have here. Okay, so this is the software we are using. So the name of the software is GrabCAD Print. So for different machine we have different softwares. Like suppose here I can open this. So you can see this is a software we are using, that is for multi-jet printing. So this machine. So we have this machine. So we'll show it later. We can see it. So in the demo class I showed you about this machine. So here in this machine the technology used is different. Here they are using small multiple nozzles there, and the material we are putting here, this is the material section, this is the material thing we have here. Just show you. So similarly with this machine we have model, we are having model material. So these are model material used for creating only the 3D printing parts, and this part is used for only giving the support. Fine. So you can see this one. Fine. So this is a liquid. So when we put it inside the machine, it is in powdered form. After putting it into the machine and heating it up, it will heat and it will melt the material. So previously it was in the form of wax, that is a solid part. Now it is liquid. You can see this is the liquid. Fine. So only difference is that we are using here multiple nozzles, and this are liquid, in liquid form. Both the model and the support materials are in liquid form. These are pumped into the machines and carried to the head section. Similarly we had I showed you the head there. We have some head here, the printing head. So the pump is carrying the liquid material to the head section, and from the head section we have this nozzle, multiple nozzle, maybe 200 or 100 number of nozzles, 200 number of nozzles, 300 number of nozzles. So multiple nozzles are there. So once the liquid is pumped to the head, so nozzle is only spraying the liquid part. So it will spray the sprayed part will get stuck into the build platform. After that it will build the printing part. So this one also layered by layered we are having the printing part. The print is happening layer by layer. So this is the machine we have here. The technology used is, this is called multiple jet printing. So that is MJP printing. Fine. Okay, so this is the part we have here, and for all the machines we have different software. Fine. So we can see here. So talking about this machine, you can see this one. It is saying that Project MJP 3600 Max. So that is the model number, and here MJP means multiple jet printing. Fine. So we have this thing. So here we model the thing. We go to file, simply we go to import. We have this thing. These are the some of the parts we have here. So let's say we select one. It is loading now, and we have this one part. It is red in color. It is saying that the geometry is too big for the print for the machine. So we can do that thing. Fine. After suppose I need to reduce the size of this geometry, I'll just go to transform. We have scale here. Select this one. This is the move option. If I select this one, I can move this one. Fine. We have rotate option, so I can rotate this one. Fine. Okay. We have scale option here. So this scale I can reduce it. So it is showing here the absolute scale. We have in X direction we have 370 mm, that is 37 centimeter. In the Y direction we have 70 mm, that is 7 centimeter, and then in the Z direction we have 365 mm, that is 36 centimeter. So that is too big for the machine to print this one. So we can do one thing. We can select this one. This is a uniform scale and it is ticked. If I make any changes here, so uniformly in the X direction, Y direction and Z direction it will change. So that is uniform scaling. If I untick it and try to change this one, maybe I'll click here from 100 to 80. So only X will change, Y and Z will remain same. If I take this one, uniform scaling, and if I change this one to 50%, so everything will change. Now everything got changed. Y became 35 and Z became 182. Previously it was 365. Fine. We can move this one inside. Fine. Okay, let's first of all rotate it. after rotation moving, so we'll move inside. Talking about view, we have this number of views we have, that is isometric view. This is the top view. From the top we can see this one, so we are going to place it over the, and this part I'll show you, and this part, this is the part, it represents the bed or the built platform where the printing will take place. Fine. So we just need to drag it to the build plate where the printing will happen. We have similarly front side, so this is the frontal portion we can see. So with this part we can see now this is our base, and from the base it is at a distance. Fine. So if I print this one, all this empty space will be filled with support material. You got it? Because from the top view, from the isometric view, you can see this one. This is our base where we need the printing. Fine, but it is at a distance from the base, so this empty space will be filled by the support material. So this will take our time unnecessary. We are spending our money on support material because unnecessary we are filling all this thing. So we can customize and we can optimize all these things. So optimization is very important part. How can we optimize? Go to the frontal view and we can drag it down to the base. Fine. Left view we can see it is perfect. Bottom view we can see that is the bottom part of the build plate and the printing part. This is the bottom part. Back view we can see, right view we can see, top view again we can see this is the top view, and isometric view means give the overall view. So here we can see the model is attached to the build plate. Fine. So this is the part we have here. So this is only for MJP printer. That is the software. The name of the software is 3D Sprint. Fine. So we have here, we have auto place. In auto place automatically it will arrange. Fine. We have copy option. If I need multiple number of this thing, I can obviously copy this thing. Suppose multiple number, it will ask for how many number. I'm giving it 1. Okay, sorry. One number set. So we have one number of thing. In the transform section we go, we select move, and then here we have, so we can place it over this one. Fine. So from the front view I can do one thing, I can take this up and I'll just keep a minimum distance. So this minimum distance, this is the empty space, because I cannot join or overlap with the initial part. So for that I can just drag it a little bit and keep a minimum distance. So this empty space will be filled with support material. So this is the reason why support material is used. So here likewise I can have multiple number of parts I can print. Similarly I can obviously place the thing in the vertical direction also. Now we are placing the this part in the horizontal part. We can obviously put this part in horizontal direction. Fine. So I'll just move this one little bit. Fine, it's perfect I think. So top view okay, front view okay. We have minimum clearance gap we have, so the two parts does not touch each other. So we have all these thing options. Now these are the quality check we have here. We have scale by unit, what unit we need. We have other things, so these are not important. After that we have this option, that is add to queue. Once we add to queue, we can rename this one, we can add to queue. Okay, so it will now add it to the part. So that's all for this software, that is 3D Sprint. It is calculating the print estimation. So now after adding to the queue, okay, we have cartridge, we have opened the bay and we have taken out the cartridge, the printing part, so it is giving us the error. So after we add this one to the queue, it will give us the total number of time, how much time is required for the total printing. Fine. Now we are moving with this software that is used for FDM based, that is Stratasys F170 model. Fine. So we have a layout here. These are the different views. We have top view, we have bottom view, and left view, right view, front view, and then we have isometric view, back view, and isometric view we have here. We have some of the options here, so we will be looking all this thing. Fine. So in this software we can import multiple number of multiple model having multiple extension in the sense, like if you build a model in AutoCAD, so it will give you some, when you save it, you are having some options like STL, OBJ, PRT, STP, STEP, IGS, IGES. Similarly, many you have. Fine. So these are the extension of the model. Fine. So in this GrabCAD software, the name of the software is GrabCAD. In this software, we have the flexibility of adding many number of extensions. But talking about the 3D Splint software, this is the 3D Splint software. Here we can only add STL file. Fine. The files which are having extension of STL. But in this we can use as many number of thing. So I can select one. Let's say this one. So this is our 3D printed part. I just open it. So it is inserting. Now it is giving some error symbol here. Fine. So we can take the thing here and we can check. It is saying that the model is very small. Fine. So okay, the model is quite small. No problem. We'll add one more. So back, and then we have, okay, fine, we have a box here. Okay, so you can see this is the box we had here, and this is the perch tower. This is the perch tower we have here. We can move. So the height of the perch tower will be same as that of the model. Fine, because it is the main purpose of this perch tower is to continuously check the height, whether the height is correct or not. So it will have same height with respect to this one. Fine. Perch tower we had here. We can go check this option. So here, if suppose we had some problem with the geometry, suppose we have many options. Once we create a geometry, we can have multiple number of problems there, like open geometry, intersection points. Suppose two points are intersecting, the boundaries are open boundaries. Those are very complex thing. So you can see here in the display it is giving us self intersection. If the model are itself intersecting, open faces, inverted normals. So these are very complex thing. We are not going deep into this. So it is going to check all this thing, and if we have some problem with this, we can go to repair mode. Fine. So this is the repair all models. So we can repair it. Fine. We have this one. This is the slicing. Slicing shows us that how the printing will occur layer by layer. Fine. So we can actually view the thing in the this thing. So now some problem is there with the thing. Okay, because of this we have added this one also. The model is very small that it is showing. Because of this one, slicing cannot be performed. So I have to delete this one but I cannot search the thing. I cannot find the thing because it is too small. It is somewhere here in the build plate, but the thing is too small. So because of this we cannot do the slicing. This is the model info, which we are using right now. Currently we are using Fine. We have here tray setting, and here we can give the material we are using. Like suppose it is already selected here ABS, but currently we have installed ASA, so we will go for ASA. Fine. So ASA is selected. Slice height shows that what is the minimum layer it will be printing in the software. The first layer, not first layer, individual layer. So what will the thickness of the height, each layer? So it is 0.0100 in inches IN. Similarly for support material, which support material we are going to use. So since I have selected here ASA, so for ASA we can use only QRS, so we can change this one. So this is the support tip. So this one we have here. Mode setting we can go, and in the mode setting we have build plate style. What will the style of this build plate? So that is normal, that is given by the company. Full height, the perch tower, it will be in full height. These are some of the things. First layer material support. For the first layer, do we need support or not? Like I showed you in the beginning of this video, that when we have taken the model from the oven, we saw that in the base we have support. So because we have selected here first layer material will be support. So when it will print, first of all it will print the support material. After that the model material will be printed. Fine. Because we have supported here, we can obviously remove this one. This one we have a section here, that is the model setting. Here we can fill the part of what is the filling style. This is the filling style we have here, infill. So infill density will be 13%. So the overall geometry will have only 13% of the material, and we can have here the pattern. So it is written here, best use for further reducing density. That will be, density will be less when structural integrity is not primary concern. We are making something where we are not adding any kind of forces like tensile force, compressive force. We are only using this one for holding some, for keeping in my room. Like we have, I've prepared one lamp, so and lamp only we are keeping in my room, so we don't have any kind of compressive or tensile load, so we can use this one. It is saying, the software is saying this one we have double spare density. Like if I select here, we have 26% of material will be immersed into the model. So it is written here, best used to reduce overall density. So overall density is reduced while maintaining structural integrity. There we can use some kind of force, nominal force we can give. We have one more, that is 38% infill. That is, infill means how much amount of material will be printed on a particular model. Like I need 50% of the material. That does not mean that it will print half. It will complete the material. If like suppose here we have a rectangular box, so it will complete the rectangular box, no doubt. About the density or the infill, how much it is going to fill, depends on this one. 38% I'm filling this one. So it is said that best balance between material usage and structural integrity. So we are having limited number of material, so it is giving us best usage of the material, and also structural integrity it is providing. Second, we have this one. So here it is saying that best use for highly structural integrity. Suppose we are using some kind of material where we have where we are giving cyclic load, as well we are giving torsional load, we are giving tensile load. So these are high structure, and this one we have 100%. Fine. This last one is the 100%. So the density will be maximum there. It will cover each and every part. So there will be no gap, nothing. So that is the reason we cannot change this two. These two can't be changed. Fine. So this is nothing. This is giving us the body thickness. Now what is body thickness we have? Like suppose it is only giving us the layered thickness. So first of all, like suppose I am building, I am making this wall. So the initial wall will be of how much thickness? The body the thickness of the body. Like suppose we have a hollow section, we have a hollow pipe. So I am telling you that I need the hollow pipe of the outer and inner diameter. The diameter of the hollow pipe should be, the inside and outer diameter should be 5 mm, not overall diameter. The difference between inside diameter and outside diameter of a hollow pipe should be 5 mm. So it represents this thing. So if I build this one, how much inside it will go and how much thick it is going to make. Fine. So then again we have infill angle. So at what angle it is going to fill? Like we have selected this one, this one, this one. Now which angle I need? 45 degree, 30 degree. So we have this thing. We have wall thick. The wall, we need this wall we are making. So how much thick? That gives us the flexibility. Now if suppose here I am selecting 13% infill density I need, but I need the walls to be very much strong. The inside I can have 13%, but wall I need thick. So thick walls can be prepared. Body thickness also helps us to increase this one. So this gives us the flexibility. So we have, these are the thing. We have trace it, support thing. So what kind of support we have? So we have smart, sparse, basic, surrounding box. So these are the support methods. The how will be the support formation. Fine. We have arrange, so we can optimize this thing. Fine. So if I click here optimize and arrange this tray, so it will place somewhere, the geometry will be placed in somewhere else. Fine. Okay. So we have this one we have orientation. I have selected this one and I am pressing this one, so it became a vertical. One more time, selecting this one one more time. Okay, we cannot move forward. Okay, fine. So Z direction is moving. Fine. We have this option, that is the scale. Similarly in the 3D Sprint software I showed you how to reduce the scale. So we have uniform scale. If using uniform scale. If I reduce only X, everything will change. If I untick it and change only X will change. So these are the things we have here. Fine. So these are some of the things here. It shows us this one. Okay, since the LAN wire is not connected, so we have some problem here, so it is cannot take the data. So it is showing that February 18, so it is showing us the log, like how many how many parts we have printed, what was the time, this thing. So we can see here. So this is the part we have here. Fine. Now we can go to file. In the file we have this import CMD file and export CMD. So just do that. So this is the project we have here, so we can save it. So you can see we have okay, I'll show you. Okay, fine. So this, talking about this part, this was the part was having STL extension. Fine. Now if you save it, export it, so the save as type is CMB. Fine. So the machine only takes CMB, and this software helps to convert any extension to CMB. Fine. So I can save it. So maybe I'm saving it here. Save. So it is already saved. It is asking for whether I want to include the parts tower or not. So exclude the parts tower part if you plan to add the CMB to another project before printing. So before printing, if I need to shift the CMB part, so do I need the parts tower also, or just the model? It is asking. So just click include. So this thing will be included. This part will be included. Fine. So this is the basic function of the this software. It is showing failed because we had very small printing part. So because of that part I cannot find it out somewhere. It will be somewhere here. It is very small, so I have to search it. Because of this one, it is showing export is failed. So this is the basic part of the 3D printing, and the software you are using is 3D grab print, 3D grab. So this is the function of the software as well as the machine. So in the next class we will be printing some of the thing. We will be showing some of the part, talking about how do we clean the support material. Now we have this part I showed you. I'll just bring. So like suppose we have a printed part here, and now the question is how do we remove this support material. So we have a wash basin there. It's a box kind of thing where we had approx 40 liters of water. Those 40 liters of water are mixed with some kind of soap and some kind of base material, some kind of alkali material, and some other thing. So it is a mixture of water, the distilled water, some kind of soap and chemical agent. So we just need to dip it there and increase the temperature. So temperature, talking of the temperature, for different material we have different temperature, like for we have 70, 80, 60. So depending on the material, which material we are using, so we are giving the temperature there. So the heaters are heating the water along with those chemical agents, and it is removing the thing, the support material. After these are removed, we will get the proper part. Fine. So in the next class I will show you how do we print the thing. So better you get me some of the STL files, or maybe PRT or IGS or any file. Prepare some model, maybe a circular disc of 2 mm or 3 mm, not more than that. Maximum 5 mm, a circular disc, or maybe a rectangular cube we can prepare. The dimension, keep it very less, because it will take time to print the thing. For printing this small part, it took around 3 to 4 hours, so we cannot afford this much of time. So get me some of the printed parts like a circular disc or anything of smaller dimension, and we will try to print it in the machine. Fine. So in the next class we'll see how the printing is happening, how the head is moving, how the nozzle is moving. I'll show everything, how the printing is happening, how the layer wise formation is taking place. So these are the thing. And talking about the lab report, so I'll just give you the theory. We don't have any calculation here. So theory regarding the machine, we have the gantry part here, we have the oven here, the screen, the bay and everything. So just I'll give you the part in PDF format or maybe in Word format. So you just have to write it, all the thing, in your lab copy. No calculation is there, nothing is there. Some diagrams are there, obviously you need to draw those diagrams. So that's all, and thank you.